Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokwa Jr., mathematics instructor at the University of Liberia. And in my today's video, I will be looking at the continuation of the proof of properties or the rules of differentiation. And in previous video, we did the proof of the constant rule, the constant multiplier rule, the sum or difference rule, the product rule, the quotient rule, and we want to do the chain rule. So let's see how this works. Now we say if P, a function, if P is differentiable at X, that is you have P of X. And G is differentiable at P of X. That is, you have G prime of P of X. Then G of P of X will just give us G prime of P of X. Then we differentiate inside, thereby saying P prime of X. That's all about the chain rule. That's all. Very, very easy, the chain rule. And the chain rule works for problems like this. Like you have x squared plus 1 raised to the second power. So someone will say, but why I can just expand this thing and just use, other rules? What if you had x squared plus 1 raised to the power 1000? So when are you going to be done expanding it? So based upon that, you can apply the chain rule, or I will introduce another rule. You can apply the extended power rule. So the extended power rule is also similar to the chain rule, because in some problems you will have a combination of this expression plus other factors. So instead of using the chain rule, and you can just use the extended power rule. Okay, so now we have now let's look there. Please pay attention. We want to use the first principle of derivative to derive this. Now, again, the first thing we need to identify is our function called some f of x, because f of x is here, right? So f of x now is what is inside. So we have p of, no, it's g now, g of p of x. So g of p of x is our function that is within. Then we need f of x plus h. So f of x plus h is just like replacing x with x plus h. So on this side, we're replacing x again with x plus h. So we've gotten our f of x and our f of x plus h. So we can replace, we have the limit of f of x plus h is just g now of p of x plus h. And then minus, I'll just use parentheses. So minus g of p of x divided by h, as h is approaching 0. Now let's look at, similar to the proof we had for was it the product? The product rule. So we can apply similar proof in this problem. That is to say, we must attach some other factors to it. In the product, we added, some other factors or some other expressions, So, but for this case, we must attach some other factors to this expression, because we need some similarity within this numerator, within the denominator, so that we can have an expression that will give us some derivative. So what we can say is we go for the innermost portion, right? Just look there. We can take the innermost portion. So the innermost portion is p of x plus h, and then p of x. So we can say, let's multiply this expression by p of x plus h plus, right, p of x divided by p of x plus h plus p of x. Now, notice something. If I'm using plus here, I know that this original property or this original definition of derivatives does not have a positive in between. It has a negative. So, just in case we want to make this h the denominator of this expression, so you have p of x plus h plus p of x all over h, this would not give you some derivative. So it means that we must use minus and minus. Now, we have f prime of x now equals to the limit. Now what we want to do now, this expression coming on here, and then this h going there. So we have g of p of x plus h minus g of p of x, all divided by p of x plus h minus p of x as h approaches 0 times, so I'm going to take the limit on the other side as well. The limit of p of x plus h minus p of x, all divided by h as h now is approaching 0. So you clearly see that this whole portion right here is just p prime of x, which is this one. But what we need on this side, we need g prime of p of x. That's what we need on this side. G prime of p of x. Now, but look here. Within here, you have p of x plus h minus g of p of x. And then down here you have p of x plus h minus p of x. What if we bring in a substitution, right? Wherein we can say let an unknown variable represent, because we want this entire denominator to just be a single variable like the way we have here, right? So what if we say let an unknown variable, we can call that variable any variable, just anything. Just anything. Just anything. What if an unknown variable, call that variable some k? So we say let k equals p of x plus h minus p of x. So what if k is equal to p of x plus h minus p of x? And that's the first one. So then what would be our p of x plus h? So this p of x plus h, now if we can solve for it, we will have k plus p of x to just be equal to p of x plus h. Or simply you can say p of x plus h is now equals to k, right? Or we can select a variable first. So it just equals to p of x plus some k. Now, after we have done that, then we put it in. So we have f prime of x now to be equal to the limit of g of, so this p of x plus h is just equal to p of x plus k, right? Minus g of p of x all divided by this whole thing down here is k as h approaches 0. But now we cannot use h any longer. Since h is approaching 0 and we have changed this variable now to k, we can say when h is approaching 0, what becomes of k? So if we put 0 right here, we place the one with 0, this one will go out. So you have p of x minus p of x. So that is to say, k will also be approaching 0. So we can have k now to be approaching 0. So if you just see this thing keenly, the limit of, let me write this one up here, plus h minus p of x all over h as h approaches 0. So just take a keen look at this. Take a keen look at this. Comparing this and this. P of x plus h. G of p of x. So this p of x is just representing x. Right? And then this k is representing h. And then this p of x is also representing what? X, right? So it means that if this one now is p prime of x, p prime of what? X, the x that is here. So this should be g prime of the entire p of x, because p of x is representing x. Is representing x. So our g prime now will be, let's say we have g prime of, so instead of saying g prime of just x, because if this was g prime of x plus k and then g of x, it would have just been g prime of x. But since this x now has been replaced with p of x and then p of x, so it means g prime now will be p of x. Remember we told you, if p is differentiable at x, p is differentiable at x, and g is differentiable at p of x, then the derivative of g of p of x would just be equals to the g prime of p of x times p prime of x. So this is our derivative, which is f prime of x is equals to g prime of p of x times p prime of x. So this is the proof of the chain rule. So thanks ever so much for watching. See you in my next video.